So usually when we talk about digital privacy on a deep dive, we treat it like, I don't know, like putting a mass-produced padlock on a storage unit.
Yeah, pretty much. Just, checking the boxes.
Right. You get that annoying prompt from corporate IT, and you just begrudgingly type out a string of characters that meets their exact binary compliance rules.
The classic one capital letter, one number, one special symbol.
Exactly.
Okay.
And once you do that, you just assume, well, I guess I'm secure now. But today, we're looking at a piece of source material that basically tells us to just scrap the padlock entirely.
Throw it right out.
Yeah. Instead, it suggests we need to, hire liars and thieves to build us a vault.
Which is it's a complete inversion of how we typically approach cybersecurity,
Totally.
We spend so much time discussing the mathematical rigor of encryption algorithms, but this material, it forces us to abandon that sterile engineering perspective.
Right, the math-heavy stuff.
Exactly. It introduces a mental model that relies on human psychology to defeat machine logic, which is just wild.
And I think the most surprising part of this whole thing is the format. I mean, we normally pull from these dense threat intelligence reports or 50-page white papers on zero-day vulnerabilities.
Yeah, the dry stuff.
Very dry. But today, our source material is exactly 12 words long.
12 words, that's it.
That is it.
Yeah.
So let me read it for you listening. The text just reads, quote, "A good password. A good
Wow.
password is a strong combination of liars and thieves," end quote.
It hits like a Zen koan, honestly.
It really does. And it's just a screenshot. It was captured via an app called CleanShot on April 7th, 2026. And the image is quite literally just a yellow digital sticky note sitting on a desktop.
Right, and what's fascinating here is that the visual context is doing a lot of the heavy lifting.
How so?
Well, think about a digital sticky note. It's ephemeral, right? It's a scratch pad where we dump our rawest thoughts at 2 a.m., grocery list, temporary mental bookmarks, that kind of thing.
Right. Yeah, my desktop is covered in them. Just random fragments of a thought.
Exactly. So by placing this deeply architectural security concept onto a mundane yellow square, it strips away all that intimidation factor of cybersecurity.
It takes the concept out of the server room and kind of drops it right onto the end user's desktop.
Yeah, exactly.
But wait, does that informal, fleeting medium of a sticky note, does it make this profound statement feel almost like a leaked secret? Like finding a hacker's fortune cookie or something?
Oh, definitely. It frames security as a user experience problem.
But if this is just sitting on a personal desktop, what does that actually say about who this advice is for? Because we're constantly told by experts to use, complex password managers and hardware keys.
Right, the enterprise level tools.
Yeah. So does an informal sticky note philosophy even have a place in a landscape that's dominated by automated security?
It absolutely has a place, and
Yeah.
specifically because of the human element.
Okay, unpack that a bit.
So even if you use a password manager, which, by the way, everyone should definitely be doing.
Right, absolutely.
Even if you use one, that entire cryptographic vault is still locked behind a single master password.
Oh, right.
A human being has to generate and memorize that master key. And humans are, quite frankly, notoriously terrible at generating random entropy.
We really are. We just want to use the word password with a zero.
Exactly. So we look at this sticky note and see a casual thought. But this specific 12-word framework actually provides a very structured way for a flawed human brain to generate cryptographically resilient entropy.
Without needing to understand the underlying mathematics.
Exactly, without the math.
Okay, let's actually test that framework then, starting with the first active ingredient. The note explicitly demands that liars, quote unquote, make up a fundamental part of the password's DNA.
Right, the liars.
But from a behavioral standpoint, we're always taught to be authentic, right? We lean into our own personal truths to create authenticators because it's easy.
Oh, yeah. A favorite sports team the year we graduated. A childhood street.
Exactly, because it lowers the cognitive load of memorizing the credential. But okay, let's unpack this. Is this note telling us that honesty is actually our biggest vulnerability?
Honestly,
Yeah.
yes. Honesty is catastrophic to security.
Catastrophic. That's a strong word.
It is, but in the context of modern credential harvesting, truth basically has 0 bits of entropy.
Because it's predictable.
Highly predictable. When we talk about targeted attacks, threat actors rely really heavily on open source intelligence, or OSINT.
Right, because our lives are just completely indexed across social media, public records, data brokers.
Everything is out there. If your password is built around authentic, verifiable information, say, the name of your dog combined with your birth year.
Which is like 90% of passwords out there.
Sadly, yes.
Yeah.
But an attacker doesn't need to guess your password using computational brute force if you do that.
They don't.
No, they just scrape your digital footprint, they compile a custom word list of your personal truths, and they just feed it into a cracking rig.
Okay, so even if I meet the IT department's complexity requirements, like I capitalize the dog's name, I throw in an exclamation point at the end, I haven't actually made the password secure.
Not at all.
I've just added, what, a minor speed bump to a targeted dictionary attack.
You've barely even added a speed bump, to be honest.
Wow.
Password cracking tools use rule sets that automatically apply those common human substitution patterns.
Oh, so they know I'm going to capitalize the first letter.
They know you capitalized it. They know
Right.
you probably appended a 1 or an exclamation point at the end. They know you substituted the letter A with the @ symbol.
Because everyone thinks they're a genius for doing that.
Exactly. But the underlying base word is still your dog's name. It's still the truth. So when you introduce the liar element from the sticky note, you are intentionally severing that cryptographic link between your public identity and your private access.
You intentionally construct a false reality, meaning I have to fabricate data. Like, if a security question asks for my mother's maiden name, I don't write her actual name, like Smith.
Right, never write Smith.
I write something entirely fabricated, like helicopter. Or if I'm building a password phrase, I create a statement that is grammatically intact but factually absurd.
Give me an example.
Like, my favorite color is spicy.
Yes, perfect. That false reality acts as a psychological air gap.
A psychological air gap. I like that.
Yeah, because an algorithm can ingest your entire life's history, process every single social media post you've ever made, and it will never, ever generate the phrase, my favorite color is spicy.
Because the concept defies logical human mapping.
Exactly, it's a lie.
But let's pause and look at the underlying math for a second, because I feel like deception alone seems inadequate.
Okay, where are you going with this?
Well, so I lie. I make my password helicopter. But a modern graphics card running Hashcat, which is a popular cracking tool, it can process tens of billions of hashes per
Not
second.
that easily.
So a standard dictionary attack is going to crack the word helicopter in a fraction of a millisecond. It doesn't matter if it's my actual mother's maiden name or a complete lie. The machine still guesses it instantly.
Right.
So deception fails without a structural mechanism to actually protect it.
Which brings us to the second half of the sticky notes framework.
Ah, the thieves.
The thieves, because the lie only protects you from the human element of the targeted social engineering.
Right.
But to protect against the mathematical element, the brute force computation you just mentioned, you need the thieves.
Right, because the text literally says, a good password is a strong combination of liars and thieves. But I have to say, this feels incredibly counterintuitive.
How so?
Well, the entire function of a password is to keep malicious actors like thieves out of our infrastructure.
True.
So why on earth are we inviting the archetype of a thief into the very foundation of our defense model? It feels like an Ocean's 11 heist movie. It's like hiring the world's greatest safecracker to design a vault that nobody else can break into.
That's actually a brilliant analogy. Think about the operational mechanics of a thief.
Oh.
A thief doesn't respect boundaries or context or rules of ownership.
Right, definitely not.
They extract assets from secure locations and they repurpose them. So when you apply that adversarial mindset to credential generation, it means abandoning the rules of syntax and language entirely.
Okay, so it's not just making up a fake sentence anymore.
Right, you don't just invent a lie. You steal disconnected concepts, raw words, and unconventional characters from completely disparate domains.
Okay, walk me through what that actually looks like in practice. How does adopting the mindset of a thief change the actual string of characters I am typing into a login prompt?
So if a polite, rule-following person builds a password, they construct a coherent sentence. They might use camel case to separate the words, capitalizing the first letter of each word.
Like the my favorite color is spicy example.
Exactly. It's a lie, but it's polite. But a thief pillages.
They pillage the dictionary.
Basically. They might steal a specific noun from, like, a manual on marine biology, then lift a verb from a 19th century poem, extract a misspelled vegetable from a random grocery receipt.
This is getting weird.
And then they forcefully bolt those components together using punctuation stolen from a calculus textbook.
Wow. Okay, so it's the chaotic acquisition of random entropy. It's basically the diceware method, but
Wow.
framed as a psychological exercise.
Yes, exactly.
And for anyone listening who might be unfamiliar, diceware is a method where you roll physical dice to randomly select words from a massive pre-established list.
Hmm.
And the math basically guarantees that the resulting phrase is so statistically improbable that no computer could ever guess it within the lifespan of the universe.
Right, and what the sticky note is giving us is the diceware philosophy without needing the physical dice.
Right.
The goal is combinatorial explosion. If you take four completely unrelated words that have literally never appeared next to each other in the history of human literature, the number of possible permutations becomes astronomically high.
But wait, let me push back again. If a computer can run 100 billion hashes a second, what difference does it make if I steal a word from a poem or a tractor manual?
Because of the sequence.
But a massive dictionary attack still has all of those individual words in its master word list somewhere, right?
It does, yes. But it's not about the individual words. It's about how cracking algorithms process the sequence of those words.
Okay, clarify that for me.
Cracking rigs do not just blindly guess every possible combination of characters or words.
They don't.
No, that would take way too long, even for supercomputers, once a password hits a certain length. Instead, they rely really heavily on Markov chains and probabilistic models of language.
Okay, Markov chains, meaning the algorithm is playing the odds based on how humans naturally type.
Exactly that. A Markov chain basically calculates the probability of one character or word following another.
Okay,
So if the cracking algorithm sees the sequence Q, it heavily weights the probability that the next letter is a vowel.
right, because that's just how English works.
Exactly. Or if it identifies the word breaking, it prioritizes guessing words like news or bad immediately following it. The algorithms are highly optimized to exploit the structural rules of language because humans almost always subconsciously follow those rules.
Ah, so the thief method completely defeats the Markov chain
You got it.
because the sequence of characters falls entirely outside the probability curve that the algorithm is optimized for. The algorithm is looking for a predictable linguistic pattern, and I've essentially fed it a ransom note made of magazine clippings where the syntax is totally obliterated.
That's exactly what it is. The original meaning of the words has been entirely stripped away by the act of stealing them.
Wow.
By forcefully jamming, say, bivalve, sorrow, turnip spelled with two N's, and a sigma symbol together, you push the computational requirements out of the realm of probabilistic guessing and into the realm of pure brute force.
And pure brute force against a mathematically long phrase is computationally unfeasible.
Exactly. You've generated an immense amount of entropy simply by refusing to play by the grammatical rules the computer expects.
Man, that is so cool. And that structural chaos brings us back to the actual chemistry of the sentence on the sticky note.
The strong combination.
Right, the text literally says, a good password is a strong combination. It demands this deliberate synergy. We have the liar and we have the thief. How do these two concepts mechanically interact to create an asymmetric defense?
Well, the liar and the thief basically cover each other's blind spots. They address two completely different vectors of attack.
Okay, let's play this out. Let's say an attacker tries to compromise my master password vault.
All right. First, they try the targeted approach. They scrape your LinkedIn, your public tax records, your Instagram. They build a custom dictionary of everything you care about.
Right, the OSINT phase?
Yeah. But the liar defeats this phase. Because your password revolves around the concept of, I don't know, a denim moon, the OSINT phase yields zero actionable intelligence.
So the human-driven attack hits a brick wall, and then the attacker pivots to the machine-driven attack.
Right. They load up a massive GPU cluster and attempt to mathematically reverse engineer the cryptographic hash of your password.
Here come the Markov chains.
Exactly. They apply their Markov chains and their substitution rule sets, and this is where the thief steps in.
Oh, I see.
Even if the algorithm somehow magically guesses a piece of the lie, the chaotic, stolen structure surrounding it prevents the algorithm from capitalizing on that guess.
Because there's no logical flow to follow.
Exactly. The sequence has too many bits of entropy. The computation time stretches from minutes to millennia.
Wow. So the lie protects the theft from the human, while the theft obscures the lie from the machine.
Yes. The combination creates a paradox that literally breaks the foundational assumption of password cracking.
Which is that humans are predictable.
Right. Cracking algorithms assume that beneath the ciphertext, there is a rational human being who followed some kind of internal logic.
But when you channel a liar and a thief, you remove the rational human from the equation entirely.
You do. The logic becomes aggressively hostile to being understood.
I love that.
Yeah.
Aggressively hostile to being understood.
Right.
But I want to look at how this applies to the modern security stack, because a lot of people listening to this might be thinking, I use an enterprise-grade password manager. It generates random 25-character strings for all my accounts automatically.
As they should.
Right. So I don't need to lie or steal because the software does it for me. Does this sticky note philosophy become obsolete when we automate entropy?
Actually, it becomes even more critical, but its application narrows.
Okay, what do you mean?
Well, you shouldn't be memorizing passwords for your email, your bank, your social media. You should absolutely let the password manager generate those massive random strings.
Let the machine do the heavy lifting.
Right. But the architecture of a password manager relies on zero-knowledge encryption.
Meaning the company hosting your vault cannot see your data.
Exactly. The only key that decrypts your entire digital life is the single master password that lives solely inside your brain.
Right. And if you forget it, the data is gone forever. If someone guesses it, they have everything.
And that single point of failure is exactly where the sticky note comes in.
Oh, because I can't use a machine-generated string for that.
No, you cannot use a machine-generated 25-character string of gibberish for your master password because you will eventually forget it.
Guaranteed.
Right. You need a phrase that is memorable to a human, but mathematically complex enough to withstand an offline dictionary attack if the password manager's servers are ever breached and the encrypted vaults are stolen.
Okay, so you need a mnemonic device that essentially doubles as high-grade cryptography.
Yes, and the liar and the thief provide exactly that framework.
So back to my favorite color is spicy idea.
Right, but combined with the thief. My favorite color is spicy, combined with stolen, disjointed vocabulary, gives you a phrase you can vividly picture in your mind.
It's bizarre enough to be highly memorable.
Exactly, but it's mathematically chaotic enough to protect your master vault.
It is genuinely fascinating how a fleeting 2 a.m. thought captured on a screen in 2026 can unpack such a robust technical architecture. I mean, we started out looking at 12 words on a yellow square, and we've walked through dictionary rainbow tables, bits of entropy, and Markov chains.
Yeah, we've really moved away from viewing security solely as a mathematical equation to be solved by IT,
Definitely.
And we started viewing it more as a psychological discipline. We are utilizing human creativity to intentionally break the probabilistic models that machines rely on.
Right. We've learned that a truly secure authenticator shouldn't be polite. It shouldn't be a reflection of our authentic selves.
No, not at all.
It needs to be deceptive, ruthless, and syntactically chaotic. To protect our digital footprint, we just have to let go of the idea that our keys should represent us. They shouldn't. They should represent the chaos our adversaries are entirely unprepared to process.
Which honestly leaves us with a rather profound implication regarding the broader landscape we're all navigating right now.
Ooh, okay. Let's hear the final thought. What are you thinking?
Well, think about it. If the underlying architecture of our digital locks requires us to adopt the operational mindset of criminals
Right.
to actively channel deception and theft just to secure our foundational data, what does that actually say about the inherent trust models built into the modern internet?
Oh, wow.
If authenticity is mathematically a vulnerability, are we structurally forced to become a little bit corrupt just to preserve our own privacy?
Man, that really changes how you view the padlock. We want security to be clean, binary and honest. But the murky reality of the internet's mathematical models demands something else entirely.
It really does.
It demands that we abandon the sterile engineering, embrace the chaotic messiness of a yellow sticky note, and learn to lie and steal just to keep what's ours. A labyrinth of liars and thieves. Something for all of you to consider the next time you are forced to generate a master key.